Okay, so today we're going to do the last section of chapter 9, and then we will spend Tuesday, Wednesday, and Thursday reviewing, and then we will take our test on Friday, okay, which is the last day of the quarter, and yes, it'll go in your third quarter grade, okay? So today 9.6 is equations of lines and planes. And we're going to find equations for lines and planes in a 3D coordinate space. So the parametric equations for a line, do you guys remember that we found parametric equations in chapter 8? We used the parametric mode on our calculator. Do you guys remember what the input was for both of the equations, x equals and y equals? What was the variable? T. Okay, so you're going to notice now, instead of having two equations, x and y, we have x, y, and z. So your parametric equations are going to be created, and it's going to be they're going to be created by going through the point P, which is going to be your x sub 0, your y sub 0, your z sub 0, and it's also going to be parallel to a given vector v. Okay, and then here's going to be your parametric equation setup. So x equals x sub 0 plus at, y equals y sub 0 plus bt, and z equals z sub 0 plus ct. So notice that for the point, the x sub 0, the y sub 0, and z sub 0, that's going to be the first part of your equation. And then how would we describe what a, b, and c are in the equations? Well, a, b, and c are coming from the vector. In your parametric equations, though, how would we describe where those are? What do you guys think? How would you describe where a, b, and c are? Yeah, what did you say? These are going to be parallel to the vector, but how would you describe where a is? Eddie, how would you tell somebody where that is? A, B, and C are all where? Okay, so is it fair to say that A, B, and C are the coefficients of t? Okay, if this is a linear equation, A, B, and C would be called the what? The slope, right? It's in front of your variable. And this is where t is going to be any real number. T is going to be the variable that is in our equation. All right, so for example 1, we are going to find parametric equations for the line that passes through this given point and is parallel to the given vector v. Okay, so I'm going to have you guys do this, and your x sub 0, your y sub 0, your z sub 0 is going to correspond to that point P, and then your a, b, and c is going to be vector v. Okay, so I'm going to give you some time now to construct those three equations from the point and the vector. Okay, so then your first equation, once you plug in your x sub 0 and your a, is going to be negative 1 plus 3t. Okay, your y is going to be equal to 3 plus 2t. And then your z, you have 0 plus 5t, which is just going to simplify to 5t. Okay, how'd you guys do with that one? All right, now for example 2, you're going to find the parametric equations for the line that passes through those 2 points. So in order to create our equations, remember, we have to have a vector. So we are going to create the vector from the 2 points. Right? Henry, how do we make a vector when we're given 2 points? You have 2 points, how are you going to find the vector that goes between them? Yep, so you're going to subtract the terminal point minus the initial point. Okay, so here's your initial point, 1, -6, 3. Here's your terminal point, and then I want you guys to find the vector. Okay, and then Kaden, will you tell me what your vector is?
1, 1, 2.
Good. Okay, so your vector is 1, 1, 2. Now your second step, you are going to find the parametric equations using the vector that you found in step 1, and you can use any point above. Okay, so what I'm going to use is the initial point. Okay, but you could use either one of those points. So your vector is going to represent the A, B, and C. And then your point is your x sub 0, your y sub 0, your z sub 0. So go ahead and create your parametric equation. Okay, Colin, can you tell me what you got for your x equation?
X equals 1 plus t.
Good. Okay, so x is going to be 1 plus t. JC, what'd you get for y?
-6 + 2.
Okay, good. -6 plus t. And Josh, what'd you get for z?
Z equals 3 + 2.
Good. 3 plus 2t. Now, if you use 2, -5, and 5, here are the parametric equations that you would create. Now, even though these look different, these equations are going to describe the same line. I don't know if you guys remember when you were in Algebra 1 and you had to identify whether 2 lines were parallel, intersecting, or the same line coinciding. So even if 2 equations look different, if they were coinciding, they represented the same line. Okay, this is a similar concept. Okay, so even though these look different, they are going to represent the same line. Okay, questions for me so far? All right, let's go to the back. All right, so the next thing we're going to talk about is the equation of a plane. So a plane in space is going to be determined by a point in the plane and the vector n. That vector is going to be orthogonal to the plane. Okay, what does orthogonal mean? What does orthogonal mean? Perpendicular, right? Okay, so it's perpendicular to the plane. That orthogonal vector is called the normal vector. Okay, so the vector that's perpendicular is called the normal vector. Okay, last week we found something that was perpendicular. What was that called? What were we finding last week that created the perpendicular vector? The cross product. Okay, remember the cross product always created the perpendicular vector? Okay, so let's look at our equation of the plane. So it contains the point It has the normal vector. Again, the normal vector is what's orthogonal. And then we can substitute those values into this equation. Now, whenever we substitute them in, we are going to simplify this equation. So if you're simplifying for given values, what's probably a property you're going to have to use to simplify?
Distributive.
Yeah, the distributive. Okay, and then you'll combine your like terms. Okay, and then instead of it being equal to 0, you are going to move whatever constant term you have to the right side of the equation. All right, so we have to find an equation of the plane that passes through the points P, Q, and R. So in order to do that, we have to have a normal vector. Okay, and since the normal vector is orthogonal, that means we're going to have to find what? We're going to have to find the cross product. Okay, so the normal vector is going to be the cross product of PQ and PR, because we know that that would be perpendicular to both vectors, PQ and PR. And if it's perpendicular to those two vectors, then it's going to be perpendicular to the plane that is through those 3 points. Okay, so again, we're using the cross product because we want the normal vector, which is orthogonal to the plane. Okay, and if it's perpendicular to the plane, then it's going to be perpendicular to the plane between those points, P, Q, and R. Okay, so the first thing we're going to do is find the vectors PQ and PR, then we'll find the cross product. Okay, and notice that you do have the cross product written for you on your sheet, so you don't have to look back and forth. Okay, so since we're given points, we're going to have to create PQ and PR. Okay, Cameron, remind us how we're going to find PQ and QR. If you're given points, how do you find the vector? Well, you can't do the cross product until you have your vectors. So if you're given points, how do you create the vectors? We did the same thing on the front side, right? When we're given points, how do you find the vector? Liam, how do you find the vector if you're given points?
Subtract them.
You subtract them. So Cameron, you're going to do the terminal point minus the initial point. Okay, so that's what I want you guys to do first. Okay, so if it's PQ, you're going to do Q minus P. If it's PR, you're going to do R minus P. Okay, and then from there you can do the cross product. Okay, Cheyenne, what'd you get for PQ? 2, 0, okay, good. 2, 0, -5. Okay, Michaela, what'd you get for PR?
0, -3, -1.
Good. 0, -3, -1. Okay, so I know some of you have already started the cross product, so you can keep going with that. If you need help getting started, remember you're going to think of PQ as your A sub 1, A sub 2, A sub 3. PR would be your B sub 1, B sub 2, B sub 3. Okay, and then once you finish that, just check with your ELBO partner to make sure you guys got the same cross product. All right, Logan, what'd you get for your cross product?
Negative 15
Yep,
and 6.
negative 15,
Negative 6.
2, and negative 6. Good. Okay, so for the first one, 0 minus 15 would be negative 15. 0 minus negative 2 is plus 2. Negative 6 minus 0 would be negative 6. Okay, now your vector, that's going to be your A, your B, and your C. Okay, and then for step 2, I said to use point P to obtain that equation. Okay, so go ahead and plug those in, and then are we going to simplify? Yes. Okay, remember we wrote that up earlier that we're going to simplify the equation? And we talked about how we were going to use what to help simplify? The distributive property. Okay, so go ahead and do that. Okay, so once I plug in my A, B, and C, and then my x sub 0, y sub 0, z sub 0, I'm going to distribute the negative 15, negative 15x minus 60, and then I'll distribute the 2, 2y minus 6, distribute the negative 6, negative 6z plus 36, and then I'm going to combine all my like terms. Okay, so I have negative 6 and 36, which would make 30, negative 60, and 30 is going to be negative 30. Okay, and then your last step is just to move that constant term over. Okay, so your equation is going to have x, y, and z on the left side of the equation, and then your constant term, or in some cases it might be 0, on the right side. Okay, now for step 2, we use point P. But you can use any point in step 2 to obtain the same equation. Okay, so you're going to choose if you want to use Q or R. So just pick either one of those, and we're going to use that to check.
That's what you're supposed to do. It's either Q or R, pretty tough. It's the same equation.
Okay, what happened? Did you guys get the exact same equation?
This one.
That I use Q, okay, and yes, I did. So, if you happen to have extra time on your test, right? If you chose point P and you got an equation, you could choose another point and make sure you got the same thing. Okay, so you should get the same no matter which equation that you use. All right, so here is your homework for 9-6. And then keep out your worksheet because I am going to go over the answers for